Good morning, student. Let us study the next topic of current electricity. The next topic of the current electricity is what we have to study. What is wheatstone's network? So in the examiner will ask the question like this: describe the construction and of wheatstone bridge or wheatstone network. Also obtain the balancing condition for wheatstone network. Students, what is wheatstone network? For that, first we have to understand the circuit of wheatstone network. The circuit of the wheatstone network bridge is as shown in the figure. What we observe, it consists of 4 resistors: R1, R2, R3, R4. It is connected like as shown in the figure. The galvanometer is connected between point B and D. The EMF of battery E and key K, plug key K, is connected in series between point A and C as shown in the diagram. So this is basic electrical circuit of wheatstone bridge. Let us consider current flowing through the main branch is what I. When we reach at point A, it is divided into 2 currents. Say current I1, current I2. Current I1 is flowing through the branch AB. I2 is a current flowing through the branch AD. When I1 move further and reach at point B, again there are 2 branches. In one branch, the current flowing through the galvanometer is what considered as what Ig. So what is the current flowing through the branch BC is what I1 minus Ig according to Kirchhoff's first law. Since current flowing through the branch AD is what I2 and current flowing through the branch BD is what Ig, both are what incoming current reaches at point D, there is a one and only branch coming out, and what is the current flowing through that branch is what? Addition of I2 and Ig. The current flowing through the branch DC is what? I2 plus Ig. When I2 plus Ig and I1 minus Ig reaches at point C, then what is the output current? I1 plus I2, which is what your I. The student, this is the basic circuit diagram of wheatstone bridge network with current distribution. Now we have to understand what is the balancing condition for wheatstone network. Student, balancing condition for wheatstone network is the voltage at point B and D should be same. What do you mean by that? The meaning of voltage at point B and D is same means what? VB equals to VD. When VB is equals to VD, the student current flowing through the galvanometer is always 0. So what is the balancing condition for the wheatstone bridge is what? Current flowing through the galvanometer is what? 0. I have written in theory, the current flowing through the galvanometer is what? 0. It's a balancing condition for galvanometer. Student, after applying balancing condition on the wheatstone bridge, we will get one more derivation. The derivation formula is like this: R1 upon R2 is equals to R3 upon R4. Written mathematically like this. So what is balancing condition? After applying balancing condition on the wheatstone network, we get the formula R1 upon R2 is equals to R3 upon R4. Student, we need to prove. So let us study the proof of this derivation. Student, for that we observe that the wheatstone bridge consists of what? 2 loops. Say first loop is what? A, B, D, A. Second loop is what? B, C, D, B. We will apply KVL for the loop A, B, D, A. When we apply KVL to the loop A, B, D, A, my direction is what? Clockwise. When I move from A to B, what is the component come across? R1. What is the current flowing through the R1 is what? I1. So what is the voltage potential difference across R1? I1 into R1. Since direction of tracing is same as the direction of current, then product is what? Negative. So here we put what? After applying KVL, what is the product of I1 and R1 is what? Negative. Then we will move from B to D. What is the potential difference across galvanometer? Is current flowing through the galvanometer into resistance of galvanometer. What is the resistance of galvanometer here? G. Current flowing through the galvanometer is what? Ig. The potential difference is what? G into Ig. My direction of tracing is what? From B to D. Direction of flow of current is also from B to D. It is same, therefore product is what? Negative. Product is what? Negative. So Ig into G is what? Negative. If I move further, A to B, we completed the path. We complete the path from B to D. Now the next path is from D to A. What is the component come across? R3. What is the current flowing through the R3 is what? I2. The multiplication of I2 and R3 is a potential difference across R3. But my direction of tracing is D to A, and direction of current is from A to D. The direction of tracing and direction of current is opposite. Therefore product is what? Positive. The student, R3 into I2 is what? Positive. Since loop is completed, therefore it is equals to 0. But since we apply the balancing condition, since bridge or network is balanced, what do you mean by balance? The balance means what? Current through the galvanometer is always 0 ampere. If I put the value of Ig equals to 0 ampere in above equation, what are remaining terms? Minus I1 into R1 minus 0 plus R3 into I2 equals to 0. Minus I1 R1, I'm going to shift in the right hand side, becomes what? Positive. Then simple mathematics we apply. R3 upon R1 equals to what? I1 upon I2. Now we will apply KVL for the second loop, B, C, D, B. Let us apply. My direction of tracing is what? B, C, D, B. Let us consider first path, B to C. What is the potential difference across R2? What is the current flowing through the BC? I1 minus Ig. So what is the potential difference? I1 minus Ig into what? R2. So students, I1 minus Ig into R2. My direction of tracing is same as that the direction of the current. That's why potential difference is what? Negative. Let us move further from B to D. If I move from C to D, if I want to move from C to D, what is the old components come across? R4. What is the current flowing through the R4 is what? I2 plus Ig. So what is the potential difference across R4? I2 plus Ig multiply by what? R4. Since my direction of tracing and the direction of current are opposite, that's why it is plus. Moving further from D to B, the voltage across G, potential difference across G is what? G into Ig or Ig into G. So Ig into G, we observe that my direction of tracing and direction of current is opposite. That's why it is plus. Since loop is completed, equals to what? 0. Again here you have to say like this, since bridge is balanced, bridge is balanced, means Ig is what? 0 ampere. If I put the value of Ig, students, if I put the value of Ig, minus I1 into R2 is the remaining term. Here Ig is 0. plus I2 into R4. Since Ig is 0, then it is equals to 0. I will shift negative term towards right. So I2 R4 equals to I1 R2. Therefore, R4 upon R2 equals to I1 upon I2. Students, this is equation number 2. From 1 and 2, what we observe? We observe that right hand side I1 upon I2 is same. Therefore, left hand side is also same. What is the left hand side here? R4 upon R2 is equals to what? R3 upon R1. If I apply mathematics rule, if I shift R1 in the left hand side, so R1 upon R2 is equals to R3 upon R2. So students, we already seen this balancing condition and we hence prove